mesmerizing. As humans, we can only hope to achieve a small fraction of the power Mother Nature can generate in a single second. A volcanic eruption, a tropical storm, an earthquake. These events are all colossal displays of frightful natural forces. Still massive, but somewhat less terrifying, are the powers generated by wind across a prairie, the wild forces at play in a thunderstorm, and the flow of current in an ancient riverbed. Through the application of science, we have learned to harness these forces of nature to power our cities and industries. Let's look at an example. A hydroelectric dam spans a strong river. A natural force, the strong flow of water, is captured and converted to electricity that is then sent down power lines to be used by people like you and me. Let's take a closer look at how engineers and scientists can make that happen. After the dam is built, the flow of water in the river is restricted and water builds up to form a reservoir. The water from the reservoir is concentrated and flows through intakes, past the control gate that controls the force of the river's flow, and into the dam. From the control gate, the water current passes down the penstock and over the blades of the turbine. The water pressure here is extremely powerful as water is pushed over and through the turbine. The force of the compressed water is strong. It rotates the blades of the turbine, which in turn spins the generator. The water flushes out past the turbine, through the outflow and into the riverbed to continue its journey to the sea. The generator contains many strong magnets. As opposite poles of the magnet spin rapidly in the generator, electrons are cast off and captured by heavy wires in the powerhouse. Huge transformers in the powerhouse convert the electricity to the correct voltage so it can be used by everyday citizens. Power lines carry the electricity over many miles to cities and towns, businesses and homes. The electricity produced by the generator can be measured in gigawatts. That amount of electricity is enough to power everything and everyone in several large cities. Hydroelectric dams have been used for over 100 years to generate power, but human engineering has also allowed us to harness the power of wind in a similar fashion to generate power. Ever seen one of these? A wind turbine is spun by the force of the air passing over its blades, not unlike the water turbine turned by the force of water. These examples show that harnessing the raw power of nature to provide sustainable energy for civilization requires a balance in Earth's 4 spheres. Humans, as part of the biosphere, build the dam and electrical powerhouse, run the power lines, and operate the functioning hydroelectric operation. The hydrosphere, of course, provides the water. The geosphere forces the water to run into a river and provides the stone and concrete for building the reservoir and the dam. Lastly, the atmosphere contributes rain, which adds water back to the hydrosphere. Interactions between the spheres of the Earth are complex. If a dam isn't built and managed carefully, it can affect all 4 spheres negatively. Normally, a hydroelectric dam is considered a clean source of energy because it does not produce carbon from burning fossil fuels. While hydroelectricity benefits people and reduces pollution, it can still negatively affect the biosphere and geosphere if abused or overused.